It's the Integrated 2 Quadratics review, kind of in a nutshell, covering the types of problems that we've gone through and the expectation that you need to be able to perform with these type of questions and hopefully pass these on your exam. So a few things that you need to know, shouldn't be a surprise to you, the same type of things we've been focusing on. And I'm going to go through and do a couple of problems. So first one, we want to make sure that we can go through and use the notion of investigating. Well, investigate is that laundry list of things. So when we're investigating, we're actually looking for x-intercepts. We're also looking for y-intercept. We are looking for domain and range. We are looking for the vertex, as well as the line of symmetry. We want to include a graph. And last but not least, answer the opens part, which really is the concavity. So we should be able to answer some of these questions just by viewing the equation. So I know that this is a parabola, which means hands down the domain is going to be all real numbers. The range, I'm not sure of. Vertex, I'm not sure of. I can tell you how this opens, though. So if I take a look at this equation, I'm going to look at the leading coefficient, so the coefficient on the x squared term. The coefficient on the x squared is 1. It is a positive 1. So that tells me that this is going to be concave up. Okay, let's see if we can find some of this stuff. So x-intercept. Well, remember, to find an x-intercept, we need to plug in 0 for y. So plug 0 into the other part of the equation, the other variable of the equation. So I'm going to do 0 is equal to x squared plus, minus 4x plus 3. Now you choose your method and how you prefer to solve this. I'm going to go ahead and factor this quickly. I know that I have an x squared term and I have a 3 in opposite boxes from each other. We're going to go ahead and multiply those two to figure out what goes in the top of the diamond. Go back to the original equation to figure out what goes in the bottom. I know to make this happen, it's going to be a negative 3x and a negative 1x. Those are going to go inside the empty boxes, and then we're going to factor x minus 1, x minus 3. So I'm going to replace this with x minus 1 and x minus 3. Using zero product property, find where your multiplication occurs, set each one of these equal to 0, and then solve. So we'd have to add the 1 to the other side, and we'd have to add the 3 to the other side. But that's not my answer. Remember, I need to write them as points. So we got 1 after we plugged in 0, and we got 3 after we plugged in 0. Okay, same idea for the y-intercept. For the y-intercept, we want to plug in 0 for x. So I'm going to take y equals, everywhere I see an x in the equation, I'm going to plug a 0 in. So doing my scratch work off to the side, 0 squared is going to give me 0. 4 times 0 is 0. 0 plus or minus 0 is just 0. And then plus 3. So it looks like I'm going to get 3. Make sure that you write it as a point. This is 0, 3. Okay. I think we can find the vertex at this point. So to find the vertex, so again, doing my scratch work off to the side here, I'm going to take the x values of the x-intercepts, 1 and 3, and I'm going to average them. So that is going to give me 4 over 2, which is 2. I need to be able to plug that back into the equation for my x's to be able to figure out what the y value is going to be. So that's going to give me 4 minus 8 plus 3. Looks like that's going to be negative 1. So I think my vertex is 2, negative 1. Now, once I know what my vertex is, I can identify my line of symmetry. It is the x value from the vertex. So it's going to be x equals 2. And I do have my range, but we might want to go ahead and graph this before we identify what that is. So I'm going to take out my coordinate plane, think about the values that I need. It looks like I need more positive x. I'm going to go ahead and plot the x-intercepts that I found, which was 1, 0, and 3, 0. I also found the vertex at 2, -1. Plot that point. Then I also have the y-intercept at 0, 3. Then I can use symmetry from that line of symmetry to be able to find its partner. So this looks like it's 2 units from the middle, so I'm going to have to go 2 units over. So it looks like that's going to be the other location. I want to connect the dots as best I can, get a nice smooth curve. We don't want this to be sharp at all. And then from here, I should be able to determine what the range is, which you could have done just by looking at the information that you already calculated, but we needed the graph anyway. Looks like the lowest point is going to be -1. It does hit at that location, so we're going to put a bracket on it. This graph is continuous, so we can write it as a beginning and an end if you want to think about it that way. And then this thing continues on up to the highest possible number you can imagine, which the notion of that would be infinity, and make sure that you put parentheses around that. So there's an example of an investigate problem. Okay, moving on. I'm going to talk about the use of zero product property. Zero product property is when we are going to factor. So this is where you do the boxes and the diamonds. So I'm going to go ahead and start setting up the box for this one. And then at any point in time, if you want to practice these problems, so go ahead and pause the video and come back and see if you get the same thing that I do. So I'll put the 6x squared and the -5 in their respective locations. Multiply those two to figure out what goes on the top of the diamond. That's going to be -30x squared. Go back to the question and grab the thing from the middle. All right, in order for this to happen, I think we need a -15x and a 2x. Those are going to go into the empty boxes. Then from here, we want to factor. Out of the first column, I can take a 3x. Second column, I can take a +1. Remember, once you find one of those pieces, the rest of it's like a puzzle. It should be able to fit together just nicely. Double check, make sure that the multiplication works out. Then we're going to replace this. So we're going to take the base times the height, and we're going to set that equal to 0. Find where the multiplication occurs and split this problem. You're going to figure out what is going to force each of these factors to be equal to 0. So then we solve. It's going to be 3x equals -1. So we had to move the 1 to the other side, and then we're going to divide. So x equals -1/3. I'm going to add the 5 to the other side for this one, and then divide. X is equal to 5/2. And then when we write our answer, it is going to be x is equal to -1/3, or x is equal to 5/2. Okay, second problem. As it's written, not necessarily a big fan of it. You want to make sure that this is equal to 0. I prefer to have my x squared to be positive. So I'm going to leave the 2 where it is, and I'm going to move the 4x squared and the 9x to the other side. So I'm going to get 0 is equal to, put this in order, 4x squared minus 9x. That's already a +2. I'm going to go ahead and set up the boxes and the diamonds again. Now, if you prefer to factor this in a different method, that's fine. I know that I showed you a little bit of guess and check in class. So we've got 4x squared and a 2. We go through, multiply those two together. That's going to give me an 8x squared. That's going to go on the top. Go back to the question to grab the one in the middle. Looks like this is a -8x and a -1x. Put those into the empty boxes and then factor. Once you find one piece of it, remember it's like a puzzle. It'll all come together. And this will give us -2. Okay, let's replace. So we have our base of 4x plus 1. We have our height of x minus 2. I'm going to set that equal to 0. Find where the multiplication occurs. Set each one of these factors equal to 0 and solve. So we're going to minus the 1 to the other side, and then we're going to divide by 4. This one, all we have to do is move the 2 over to the other side. We're going to go ahead and put or between this. So those are a couple of examples of using zero product property. Okay, moving on. We want to be able to write an equation based off of either we're given a table or we're given a graph. In order to do this, we're going to go through and actually kind of take a look at them the same way. First thing I want to find are the x-intercepts in the table. Remember, x-intercepts are number, comma, 0. So I'm going to take each one of those and I'm going to set them equal to x. So x equals 1, x equals 4. I'm going to move the constants over to the other side. So it's going to give me x minus 1 equals 0, and this is going to give me x minus 4 equals 0. Those are my factors. So I'm going to take that x minus 1 and that x minus 4, and I'm going to start building backwards. So I'm going to do y equals. Now, chances are there is some value in front there. If it's 1, that's great, but we can't assume that it is. In order to find that a value, we're going to go back up to the table. You're going to choose one point that you haven't already chosen. So you can't use the x-intercepts. It won't get you anywhere. So I'm going to go ahead and choose 0, 24. So that means that I'm going to plug in a 24 for my y, and I'm going to plug in 0 for my x. Everything else gets dropped down. So parentheses and the numbers. Then from here, we solve. Keep the a. I know that 0 minus 1 is -1, 0 minus 4 is -4. The entire right-hand side, once you get everything figured out, is from inside the parentheses, is just multiplication. So in order to get rid of that 4, we're going to divide it. And we know that that means that a is going to be equal to 6. Not quite done yet. Need to go back to the equation where you had the a, and we're going to plug it in. So there's the 6. Then we're going to take our factors, which was x minus 1 and x minus 4. This is in factored form. So this is factored form. If you want to put this into standard form, or if it is required for you to put it into standard form, you need to multiply everything out. So my recommendation is to draw the boxes. We know the base and the height. Go ahead and fill in the boxes. Combine like terms. And then distribute the 6. This is in standard form. So if this is asked for, standard form has no parentheses and there's no multiplication between factors. Okay, moving on to the next question, number 5. Although we're in a graph, the idea is the exact same thing. So we want to go through and we want to locate the x-intercepts. So in this case, we have point 5, 0, and we have 3, 0. So we're going to rewrite those as x equals, well, I think I'm going to turn it into a half. I prefer to get rid of the fraction, so I'm going to multiply everything by 2. So that's going to give me 2x is equal to 1. Subtract the 1 to the other side, so I get 2x minus 1 equals 0. I'm going to do the same thing with the other one over here. I have x equals 3. Move it over because we want equals 0. Okay, good. We've got that set. So now we're going to do, so we're going to take y equals, we don't know what a is, take the factors of 2x minus 1 and the other factor of x minus 3. From here, take a look at the graph, and I have another point. Now, if I didn't have another point, all I would want to do is inspect the graph. I know that the graph is concave down, which means I know for sure that a is negative. I don't know exactly what it is, but I do know that it's negative. That's if I didn't know another point. In this case, I do know another point, so I'm going to go ahead and plug it in. So I'm going to plug 2 in for y, and then I'm going to plug 1 in for x. Drop everything else down. I don't know what a is. That 2 was there, and it's going to get multiplied. And then follow order of operations to solve. So I'm going to get 2 minus 1, which is 1. We'll get 1 minus 3, which is -2. So I'll get a times -2, divide by -2. It looks like a is going to be equal to -1. It is negative. That's exactly what I expected. Last thing I need to do is write the equation. I think I'm just going to leave this one in factored form since it doesn't specify. -1 as my a, and then 2x minus 1 and x minus 3. That's my equation for that one. Okay, moving on. Now, solving for x. This is in perfect square form. You'll notice by inspecting the equation that you only see one x in the equation. Whenever you see this, my recommendation is to peel away all of the things that are around the x. So if I take a look at this, the first thing that's going to have to go is the squared. So I am going to square root each side. Remember, whenever you put a square root in, make sure that you put in the plus or minus. On the left-hand side, the square and the square root cancel. And actually, I don't need the parentheses anymore. Plus or minus, I do know the square root of 64 is 8. Move the 4 to the other side. I'm not going to stack them up because of that plus or minus part. I will go through and actually do the two problems separately. So if I do the plus part, I will do x equals 4 plus 8. Well, that's going to give me x is equal to 12. Don't forget you still have the other one to do. X is equal to 4 minus 8. That's going to give me -4. Those are my two answers. Same idea for question number 7, still the idea of peeling stuff away. But in this case, you have to get rid of the 3 first. So we're going to divide each side by 3, get that to cancel. We'll get x plus 1 squared is equal to 9. Now it's the exact same process. Square root, don't forget the plus or minus in front. The square and the square root cancel and the parentheses are no longer necessary. Square root of 9 is 3. Move the 1 to the other side. We get x is equal to -1 plus or minus 3. Make sure that you do both of them. So we'll do -1 plus 3. Looks like x is equal to 2. Or x equals -1 minus 3. So x is equal to -4. Again, at any point, you can pause the video and work out these problems on your own. Okay, we want to complete the square. In order to complete the square, we want to move the constant to the other side. So if we do that, drop everything else down. X squared minus 8x is equal to -2. Take a look at the coefficient in front of the x squared term. That will tell you how many squares you're supposed to build. In this case, it's just 1. So I'm going to build a single square. Remember that you are building a square and not a rectangle, so the dimensions must be the same. So we're going to take the x squared, and then we're going to take the -8x, and we're going to split it evenly into these two boxes. Last thing we need to do is figure out what number goes in the top right-hand corner that actually completes the square. Well, the number is going to be 16 in this case. That 16 I'm going to add to both the left and the right side of the equation. So I now have x squared minus 8x plus 16, which is good because that's exactly what's inside the boxes. And on the right-hand side, I have a 14, just combining the -2 and the 16. Now back to the boxes. We want to factor this, so get your dimensions. It's going to be x minus 4, x minus 4. They better be the same since this is a square. Now, I know that I can rewrite this as x minus 4 times x minus 4, base times height. Still have the 14 on the other side. But since these parentheses match, we can write it as a squared. Now, we only have a single x in the equation. This is good. We get to proceed just like we did on the previous problems. We're going to peel away, so we're going to square root. Left-hand side, the square and the square root cancel. I have my plus or minus. I don't know what the square root of 14 is without my calculator, so I leave it as it is. Add my 4 to the other side as I'm solving for x. X is equal to 4 plus or minus the square root of 14. Although technically, if I had my calculator or if I was supposed to give approximate answers, I would type this in. two separate things, but the exact answer will suffice. Okay, moving on to the next one. Same idea. Move the 7 to the other side. We have x squared plus 12x is equal to 7. We know that the coefficient on the x squared is a 1, so we are building 1 square. If it was 2, we would build 2 squares. If it was 3, we would build 3. In this case, it's only 1. So we'll put the x squared where it belongs, take the 12x and split it evenly into the two boxes. Find the number that completes the square in the top right-hand corner. In this case, that number is going to have to be 36. That is the number that gets added to both sides of the equation. Write down what we have. So that was x squared plus 12x plus 36. It's everything inside the boxes. And then on the right-hand side, we combine like terms. Okay, back to the boxes. We want the dimensions. We have an x plus 6 and an x plus 6. Need to be the same. Remember, it's a square. So this is x plus 6 times x plus 6. Haven't done anything with the 43 yet, so just take it with you. But remember, anything times itself is squared. Now we're at where we were previously. Peel away. So let's peel away the squared. So the square root, and then the parentheses are no longer necessary. Plus or minus, I don't know what the square root of 43 is without a calculator, so I'm going to leave it as it is. Minus the 6 to the other side. I'm going to get x is equal to negative 6 plus or minus the square root of 43. Again, if I had a calculator or needed to do approximate solutions, I would grab my calculator to type them into two separate things. Okay, moving on, we want to use the quadratic formula. Well, you want to be able to identify what a, b, and c are. First, need to make sure that the equation is equal to 0, which it is. So it has to be equal to 0 for this to work. We're going to go through and identify the coefficients. So a is the coefficient on the x squared term, b is the coefficient on the x, and c is the constant. Remember, the only limitations on this are that a cannot be equal to 0. So now we take out our equation. So we know this is negative b plus or minus a big square root symbol, b squared minus 4ac all over 2a. And then we start plugging our numbers in. When you plug this in successfully, the entire right-hand side of the thing is just going to be numbers. So we have negative. My recommendation is to use parentheses when you plug in a, b, and c. So we know c is negative 7 minus 4. A was 1. C is 3. Make sure that square root symbol goes all the way across. Make sure the fraction bar goes all the way across. And then 2a was 1. Using your calculator and obeying order of operations, we know that the negative and negative cancel. And because of the plus or minus sign, we can do that because it doesn't affect the other things. Right-hand side, inside the square root, we're going to type in exactly what we see. So this is where parentheses are so important. Put parentheses around that negative 7, put the squared on the outside, minus 4 times 1 times 3. So that is going to give us 37, and then 2 times 1 is going to give us 2. Now in this case, I don't know the square root of 37, and it can't be simplified. These are my exact solutions. You could get the approximates, though. To get the approximates, you have to separate this out. So 7 plus the square root of 37 divided by 2. When typing this into the calculator, you're going to want to type in the top only. So 7 plus the square root of 37. Get your answer from that, and then hit divided by. Don't type that answer in again. Just hit divided by. It'll use your previous answer, divided by 2. This is going to give us 6.541. Approximately. Now we have to do the other one. So this is going to be 7 minus the square root of 37 divided by 2. Same process. 7 minus the square root of 37. And then that answer, so don't type it in again, just hit divide, 2. You'll get 0.458 or 0.459 if you choose to round. Okay, same idea for question number 11. Want to make sure that it's equal to 0, which it is. And in this case, identify your A, B, and C, and then plug them in accordingly. So A is 1, B is 3, and C is negative 8. Get x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Yes, you need to know the formula, so make sure that you commit it to memory. Negative parentheses, because plug b in, b's 3, plus or minus parentheses, square root, put parentheses around your b when you plug it in though. 4 times a, which was 1, and c, which is negative 8. Make sure your square root symbol goes far enough, so all the way across, and then 2 times, well, the a value here was 1. Same idea, you want to type everything in from the inside of the square root. So we're going to get 3 squared minus 4 times 1 times negative 8. That's going to give us 41. 2 times 1 gives us 2. That is going to be our exact answer because, again, I don't know the square root of 41. If I did, then I would proceed. So this is exact. Then, to get the approximate, you're going to have to separate it. Negative 3 plus the square root of 41 divided by 2. Remember, type in the top of this first. So negative 3 plus the square root of 41. Get that answer and then hit divide. Don't type in the answer, just use the answer. Divided by 2, that's going to give us 1.701 if you truncate, 1.702 if you round. Let's do the last one. Negative 3 minus the square root of 41 divided by 2. Type in the top first. So negative 3 minus the square root of 41. That's going to give you negative 9.4031242237. I'm not going to type that in. I'm just going to let my calculator hold on to that information. I'm going to hit divided by 2 with it. That's going to give me negative 4.701 if you truncate, negative 4.702 if you round.